Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in Pathfinder solution series, and I have brought forward to you a technique that is very important from the topic of oscillations, and this is something I call it as equivalent SHM technique, and these are the two problems we are going to involve this technique with, right? Check your understanding 2 and check your understanding 5, wherein you would have an alternative solution. Some of you would have worked out similar kind of problems in the past, and you would have done these problems using integration. So my job in this present video would be to take you through a situation where we can avoid integration, try to see more visually what's the problem is to offer, and get a logical and a quick solution. Okay, so also wait till the end of the video. After listening to both the solutions properly, I'll be giving you two practice problems on a similar kind of scenarios. Okay, so without much further ado, let's move forward to the two questions. The first one is this. So in case you want to give a fair try, try to take a snapshot of this particular question, or if you have the book, try to go to Oscillations, check your understanding second question, and then check your understanding fifth question from the same chapter. Have a try in your own method, and then you can try to compare it with the method that I am going to involve you with. Okay, so always having multiple views of the same problem develops your understanding of the subject, especially the theory part. Okay, so I'll start with the problem number 2. Okay, here's the formal wording. A simple pendulum consists of a bob of mass m and a thread of length L. In an experimental demonstration, your physics teacher pulls the bob aside until the thread makes an angle of 2 by root 3 minus 1 radian with the vertical, and starts pushing the bob towards the equilibrium position. While pushing, he continuously applies a force F is equal to mg along the circular path of the bob until the thread becomes vertical, and thereafter he releases the bob. For what length of time did he push the bob? And acceleration due to gravity is assumed to be g. Okay, so to just explain the pictorial idea, so he has pulled this bob, you can see on the thumbnail, to the side by an angle of 2 by root 3 minus 1 radian, and then he pushes it with a magnitude of force equal to the weight of this bob throughout this motion till the bob actually reaches the vertical position. So this particular angle that he has mentioned is under the motion with the experimental observer and also the gravity. Both the forces are continuously acting. Okay, so we need to calculate the time duration of this motion. Okay, so let's move forward, and I'll try to introduce a simple and very well-known topic for the students of SHM. I'll come back to this question after the second one. Okay, so the basics I need to illustrate my method for the second problem would be something related to a phasor diagram. Okay, so we'll try to quickly brush through this topic. So whenever a blue particle, can you see a blue particle is in UCM, which is uniform circular motion, right? Let's say this is the blue particle. Can you see a blue particle here rotating in a uniform circular motion with an angular velocity omega? That would be a constant because uniform circular motion. And then the radius vector of that particular particle on the diameter will have a projection. Okay, projection means a shadow or a x component of it. Okay, I've taken the circle center as x equal to 0 and the extremes as minus a and plus a. It's obvious that the radius vector has a magnitude of capital A. Okay, now as this particle moves on the circle, its projection moves on this diameter back and forth. Okay, so that green particle's projection is going to be in SHM. How do I know that? Because if this is capital A, the value of this x becomes a cos omega t. And we all know that any sinusoidal, that is sine or a cos function, variation of a x coordinate, means it's a simple harmonic motion. Okay, that means since these two are going to complete the oscillations in same time, not oscillation, I should say periodic motions in same time, the time duration calculations for SHM, which is the green particle back and forth, can be equivalently and easily calculated for the blue particle. Why is the blue particle's time durations easier to calculate? Because it's a uniform circular motion. You know, as in UCM, the coverage of equal angles happens in equal intervals of time. If this has to cover the angles, the equal angles will cover equal intervals of time. Can't say the same with the SHM because the equal distances won't be covered in equal intervals of time. Always uniform motions can be utilized to calculate the time in a much easier manner. So this is a basic idea. So whenever I have a time calculation in SHM, I'll try to think of a uniform circular motion. That is where the phasor diagram comes into picture. I've written some sine, cos, and minus cos and all this. This won't be used in this present diagram. I'll take up another problem in the future to illustrate the importance of these trigonometric functions that I have written. Right. So in this problem, we need to just remember the time duration part. Now, coming to the solution, I know there's a lot of things on the board. So please try to follow what I am trying to explain. So instead of going through the board all through on your own. Okay. So this is a problem number 2 that we are going to look at. So the person has pulled it aside and he's going to push it with a constant magnitude force of mg. As this bob keeps rotating, he will change this angle in such a way that the 90 degrees is always maintained, and the weight is a constant vector that is acting on this particular bob. Okay, now the angle theta at any arbitrary instant lies between 0 and 2 by root 3 minus 1. You should realize that 2 by root 3 minus 1 with a very quick calculation is somewhere around 8 to 9 degrees, which is a very small angle. So for these kind of small angles, we can always assume sine theta is approximately theta. Okay, you can actually use this up till second decimal place, up to even 15 to 20 degree angles also, whereas this 8 degree or 9 degree angle is a much small value. This is one of the important observations for this particular numerical. Okay, right. So writing the torque equation about the point of suspension P for the motion till vertical position, I am writing this only up till vertical position. Remember, we are interested only in the time duration up till this point. After that, what happens is of no interest for us. So for this part of the motion, the torque due to the applied force, remember the force is always perpendicular to this length L, will give you mgl, whereas the torque due to the weight will have a line of action like this, and perpendicular distance from the point P will be L sine theta. That's what I've written here. Both these torques would be clockwise, whereas the angle theta that you marked, and thus the alpha, which is double differential of theta, theta double dot means d square theta by dt square, that is taken as anti-clock, so clockwise, and this is anti-clockwise. So to respect that, I have put the minus sign here and plus sign here, which is important for our SHM equation. So rearranging and writing sine theta as theta here, you'll end up getting minus g by L 1 plus theta is alpha, or simply theta double dot. Now here's the trick of effective SHM. In an effective world, you can think and manipulate this theta double dot as 1 plus theta double dot. Remember, 1 plus theta is a new variable in your mind whose double differential is still this one, right? Because 1 is a constant. Why did I manipulate it this manner? Because I see a 1 plus theta on this side. So this is the trick that will avoid the integration for us. So once you write this, you realize 1 plus theta is a new variable which follows the SHM equation. Remember, any double dot equal to a minus constant times itself is a SHM equation, right? With its value during the motion changing from. Now ask yourself, as theta changes from 0 to 2 by root 3 minus 1, what does the variable 1 plus theta during this motion change from? I think 1 plus theta's lowest value during the motion is 1, and the highest value would be 2 by root 3. So you are looking at an SHM equation variable whose value is changing from 1 to 2 by root 3. For this, you need to calculate the time duration. And the omega of this equation is square root of g by L, which is a basic understanding. Okay. Now, instead of solving it using integration, now I'll convert this 1 to 2 by root 3 into an alternative problem, an effective SHM problem. Okay. So let's borrow this last line into the next page and work on it. So I have written the same line for our understanding. Okay, so I would now say that this particular time duration of 1 to 2 by root 3 in 1 plus theta variable is equivalent to, right? The time duration requested is thus same in an effective linear SHM where another variable x changes from. Now look at this, 1 to 2 by root 3 is a variation of multiplication of root 3 by 2. This number is becoming root 3 by 2. So a SHM equation, if I have another alternative problem in which a capital A is becoming root 3a by 2. Okay, I hope you understood this. When 1 is changing to 2 by root 3 in a mathematical equation of 1 plus theta, remember 1 plus theta will now become highest value of 1 plus theta into sine omega t. So whatever time this maths equation takes, the same maths equation in a different problem will take the similar time. That's my ideology. Okay, so you could see the multiplication of root 3 by 2 here also. Now I'll build this problem in my mind. That is an easier problem. A linear SHM is an easier problem for which I can draw the phasor diagram. On the blue green particle phasor diagram, for a particle to move from capital A to a x coordinate of root 3 by 2, right? This green particle should move from A to root 3 by 2. The blue particle on the UCM should move an angle of pi by 6. Can you see that? As the blue particle moves like this, its shadow or the projection moves this way to this position. So the time duration taken for the green particle from here to here is equivalent to time duration for the blue particle to cover an angle of pi by 6 on the phasor. So to repeat my ideology here, 1 plus theta, first of all, is made equivalent to a to a root 3a by 2 in a different problem. And for that problem also, we are calculating the time duration using the phasor angle. So the time duration for the green particle is equal to time duration of blue particle, whose phasor is to take rotating pi by 6 in a uniform circular motion. For an omega that we all know should be root g by L. Therefore, pi by 6 omega is the answer, and pi by 6 root L by G is the requested answer for the actual problem, which you don't see on the board right now. It is the equivalent problem that we have built to solve. Okay, I hope you understood. I know the explanation took a long time, but once the student catches this particular explanation, he can actually do it on fingertips. When he understands, only equation that he needs to write and recognize would be this in the future problems. Okay, so with that spirit, let's move on to the next question, which where also we'll try to manipulate a given problem into a different problem to understand the time and different kinematics quantities. Okay, I hope you're ready. So here's the problem. I want to again give it a try. Just wait for 2 minutes, draw your free body diagrams and try to manipulate, and don't do it using integration. So let's try to see whether you can do that or not. Okay, so I'm going ahead with the formal wording. A block of mass m placed on a frictionless horizontal floor is connected with two identical springs, each of force constant k. Right, one end of left spring is connected to a fixed support, this one, and one end of the right spring is free. Initially, the block is at rest and the springs are collinear and relaxed. If someone begins to pull the free end of the right spring with a constant velocity u away from the wall, how far will the block move before it acquires a speed equal to u? Okay, so check your understanding 5. Okay, so with the same zeal that we had in the previous problem, let's move ahead for the solution of this one. Okay, so again, a lot of things on the board, just follow my lead. Okay, so I have tried my best to depict the information given in the problem in this particular picture, and whatever I have written on this particular diagram, let me explain. This right end is pulled with a constant velocity u, he said, right? So over a period of t seconds, this end would kinematically move a displacement of ut. A constant velocity u in time t seconds moves a distance of ut. Okay, right, that is what I depicted here. Now, and imagine the block itself on its own moves towards right with a displacement of x. Okay, so if this is x and this is ut, this spring will get compressed by x minus ut. And in turn, it will push this block in the leftward direction with a k into x minus ut. A quite simple understanding. And since this block moves towards right with x, then expansion in the spring will be equal to kx. I know diagram is not showing expansion and compression properly, but these numbers will take care of that. Okay, right. So what is the total force on this block that is acting once the displacement has become x? It is the summation of these two numbers. Okay, so equation of motion as seen by the ground observer for this block m would be the backward force of kx and k times of x minus ut is equal to the forward acceleration of this thing that I have depicted, m into a. I am writing it as x double dot. Now, this is a very hard equation to solve on its own, not unsolvable, but I'm trying to avoid the integration. Okay, few students might go ahead with integration here. They can do it, but my job here is to avoid it. Okay, so what I'll do is I'll manipulate this into some form that I know, where this is 2k common, then x minus this number will become ut minus, ut by 2. Just watch this one very carefully and listen to me. Then what I'll say is, because this is x minus ut by 2, I would have preferred having the same variable here with a double dot. And then to my surprise, I can clearly see that if I forcibly write this as x minus ut and take a double dot means double differentiation, it is still same as x, because this is a linear term. Any linear terms double differential is a zero. So I can wishfully write any linear term here. So I prefer to write whatever is here. Then I would again say, if at all any double dot variable is equal to a constant times itself, then that variable is supposed to follow a SHM equation. It should oscillate with a sinusoidal equation, okay, with the omega given by root 2k divided by m. Now, what does this mean? All this mathematics is all fine. Let's try to find a physical significance for the meaning of x minus ut by 2 following SHM. Now, who measures x minus ut by 2? If a ground observer measures x, who measures x minus ut by 2 in a different frame? What's the physical significance? Let's try to answer this in the next slide. I would say ut by 2 is nothing but a constant velocity u by 2 traveling with a time t, right? A constant velocity u by 2 traveling for a time t. So I'll depict that as an observer or a frame of reference moving towards right with a u by 2. In this frame of reference, any x coordinate, I am referring to that as a capital X, is not nothing but small x of this minus u by 2 into t. So whatever mathematical variable I have created out of manipulation in the previous slide, I can give it a physical significance by saying that's a variable measured by a moving observer towards right with a constant velocity u by 2. Now ask this observer what he sees of the given problem. He would say the right end is actually moved towards right with u by 2. Remember, ground observer sees it moving by u, an observer moving towards right would watch it move towards right by u by 2. And the left end, which is actually fixed, seems to be moving backward with a u by 2. Not only that, the block which was initially at rest would be seen by this observer as having a initial velocity towards left of u by 2. So this is the initial picture he will see. Now, if this capital X has to be written and substituted in the original equation, let's look at the previous one. Remember, this is the total force that you had on the block. Remember, this is a contact force. Contact forces are frame independent, right? So the same force that would be acting on this body can be written as 2k into capital X. Okay, 2k into capital X. And he will start off by saying the capital X is 0 at the start and the velocity of the block is u by 2 in the backward direction. All this will be referred to by this person. You might argue, why will the force be only 2kx? Remember, u by 2 observer is an inertial frame. There won't be any pseudo force on it. So the force seen by ground observer and force seen by this observer would be the same. So keep this track and follow my lead. In the ground frame, the block has to achieve u in the rightward direction. What was the question about? He wanted to understand what is the distance traveled by this block by the time it achieves a speed u towards right. That's what the question was. So the block has to achieve a speed u towards right with respect to ground. Now the same information in the frame moving towards right with u by 2, the block has to achieve only u by 2 towards right, right? U by 2 towards right. So my job is to find a instant where the block, which is actually initially moving with u by 2 backward, is going to move u by 2 forward. Okay, right, which means remember this 2k capital X is an SHM type of a function as seen by this guy. So with respect to this frame of reference, this block will be in SHM moving back and forth. Okay, so this u by 2 can be achieved as you can understand that initial velocity of a block in an SHM is backward from a mean position, and over a period of time it again reaches the same position with a u by 2 forward. What does that mean? It means it is a time duration for which reversal of velocity takes place at the mean position. Okay, and what is the time duration for the reversal of velocity at mean position? Half the time period. Remember, the phasor has to rotate by 180 degrees. So half of 2 pi root m by 2k, because 2k is the effective spring constant. So the time taken as measured by the moving frame is pi root m by 2k. And we all understand time is a frame independent quantity. Whatever time this inertial observer measures, the same time the ground frame observer also has to measure. Okay, now in the ground frame, what is the displacement of the block? How do you calculate the displacement? So stay with me, it's almost done. Displacement of the block is nothing but displacement of the block with respect to the moving frame plus displacement of the moving frame. And we all know in the moving frame, the SHM happens in such a way that the block moves back and also moves forward by the same distance, right? So the displacement is 0. So displacement of the block immediately becomes only displacement of this person for this particular period. And this person is moving with a constant velocity of u by 2. Therefore, it's simply u by 2 times time. Okay, so you could see that time has been substituted, and without integration, I know a lot of explanation has happened because I'm trying to explain it in an elaborate manner, but you could easily understand that these things can be manipulated by a sharp student in a pretty quick manner within 2 or 3 minutes by avoiding the integration. So I hope you understood the spirit of the method, which should help you in future problems to avoid integration. Okay, right? And I'm pretty sure these problems given in the actual Olympiads, the spirit of the examiner was for the student to identify these patterns in the previous problem with the 2 by root 3 minus 1, and also with this kind of a scenario. Okay, so I hope you are excited to share with me the practice problems of the similar situations. I've given you an easier version, so build up your understanding number 5 from the same chapter, a train question. Okay, where time duration is asked, and the second one is the question with the concept of viscosity thrown in. Build up your understanding 20. I'll come up with the solutions for these two problems, again trying to avoid the integration and trying to be slightly more logical in building the effective SHM. Okay, so I hope you'll be ready for those by giving it a fair try. And in case you have liked this particular problem, there are other Pathfinder solutions as a series that's running parallelly in this channel, and also some other series as you could see on the board, and also some series that I have not written here. So please do go through the playlists of different series, and all the links of these playlists which are important are in the descriptions below. So directly go to the description, go through each and every series, try to watch 3 or 4 videos every day. If you are new to the channel, you can cover up to 160 videos that I have produced. Each and every video, I promise you, is unique in its presentation and a time well spent for a physics enthusiast, especially the student if he is from a JE aspirant or a Olympiad aspirant. Okay, so it won't disappoint you, I promise you that. And please do like this video. YouTube algorithm pushes the liked videos to more audience, thereby helping my channel getting more subscribers, and I would be indebted in case you keep supporting my channel. Okay, please do share this particular content in WhatsApp and Telegram relevant groups of your friends, so that they can come and access my channel and become richer in the JE physics and Olympiad physics. Okay, I hope you keep supporting me, and see you in the next video.